All right, so today we're going to continue on with this more on linear equations and talk about graphing using the intercepts. So another way to graph the equation of a line, because you only need 2 points, is to find the x and y intercept of that line. So this is probably most useful in cases like maybe you're given the standard form equation of the line like we have here, 5x plus 3y equals 30. And we want to find the intercepts to graph. So here's how you would do it. You would set x equal to 0 to find the y-intercept, because if you have a point where x is 0 and y is a number, that is on the y-axis. So that's where we would cross the y-axis. 5 times 0 plus 3y equals 30. So 3y equals 30. Then we divide both sides by 3 to get the y equals 10. So this graph crosses the y-axis when x is 0 and y is 10. Then we're going to do the same thing to find the x-intercept by setting y equal to 0. So when we set y equal to 0, that will give us 5x plus 3 times 0 equals 30. So let's get that going. Five x plus 3 times 0 equals 30. So 5x equals 30. Divide both sides by 5. And we get that our x-intercept is 6 at the point 6, 0. When x is 6 and y is 0, that's where we cross the x-axis. So then we can graph using that. We can use an x-intercept of 6. So I'll put a point at positive 6 on the x-intercept. X-axis, and excuse me, a y-intercept at 10. So I find positive 10 on the y-axis. And then we said earlier, technically we only need 2 points to draw a line. I'm going to butcher this when I do it. I don't know why, but using that envelope did not help me at all. But you can see more or less what that line should look like. It's the line that contains those 2 points. And then another thing I wanted to point out is that you can also find the slope of the line by using these intercepts. You can see this line is going down from left to right, so it should be a negative slope. And we calculate slope as rise over run. So to go from one point to the other, you go down 10 and right 6. So you could represent that slope as negative 10 over 6. And that reduces down to negative 5/3. So there's a way to get the slope from using the intercepts as well. And one more example, and we should be done. Let's do like a little real world practical use. I will buy 3 boxes of goldfish crackers. I know I usually run out after 5 days. So this is using the practical concept of what intercepts would actually represent. One big thing is to make sure you set up your graph correctly. The y-axis and the x-axis typically represent specific things. The x-axis is your independent variable, and that's almost always time. If time is one of your variables, in this case we're using days as one of them. So the time or days is going to be on the x, meaning my dependent variable is the boxes of goldfish crackers I have left. So thinking in concepts, I have 3 boxes of these crackers before any time passes. I bought 3 of them, so that's what this intercept is. The y-intercept would be 3 crackers before any time passes. On the other hand, after 5 days pass, I know I should have 0 boxes of crackers, so that would be the x-intercept. Technically, I'm not going to go any further, because if I go down this way, then we'd get into negative boxes of crackers. That doesn't really make sense. If I went this way, I'm going backwards in time. That doesn't really make sense either. It's not like before I had the crackers, I had more. I probably didn't have any at that point. So I'm just really doing a line segment rather than a full line, but that's the concept of intercepts there. After 0 days pass, I have 3 boxes of crackers. After 5 days pass, I have 0 boxes of crackers.